Suppose you have a source of light, a lit bulb, and a surface some distance away. Light from the bulb will illuminate or shine up on that surface, and illuminance is the rate at which light energy lands up on a 1 square meter area of the surface. Illuminance is a surface thing, and it depends on two variables: the rate at which light energy is given off by the source and the distance between the source and the surface. Illuminance is directly proportional to a source thing, the rate at which light energy is emitted or given off by the bulb. Technically, we refer to this as the luminous flux. While not precisely accurate, it is useful to think of it as the power of the bulb, and it is roughly equivalent to the bulb's electric power rating in watts. So a 120-watt bulb would release energy at twice the rate as a 60-watt bulb and lead to 2 times the illuminance on the surface. And if the source thing is reduced in half, for instance by using a 30-watt bulb, then it remits energy at 1/2 the rate and leads to 1/2 the illuminance on the surface. Illuminance also depends upon distance and is inversely proportional to the square of the distance between the source and the surface. Light from a bulb spreads outwards in all directions, and the further that light travels from the source, the larger the spherical surface over which it is spread. As such, light becomes diluted by distance. The rate at which light energy lands up on a 1 square meter area of surface becomes less and less the further that surface is from the source. This inverse square relationship means that a doubling of the distance causes the illuminance to be reduced by a factor of 4. Moving a surface from 1 meter to 2 meters from the source would cause the illuminance on that surface to be 1/4 as much. 3 times the distance results in 1/9 the illuminance. 4 times the distance results in 1/16 the illuminance, but making the distance 1/2 as much causes the illuminance to increase by a factor of 4. In other words, moving the surface from 1 meter to 1/2 meter from the source causes the illuminance to be 4 times greater. If both the bulb's power and the distance to the source are changed, the illuminance can be predicted in 2 steps. First, take into account changes in the bulb's power, knowing that illuminance is directly proportional to the power rating of the bulb. Second, take into account changes in the distance using the inverse square law relationship. Get organized, make the 2 changes separately in order to determine your final prediction of the illuminance on that surface. I'm Mr. H, letting you know that you got this.